Hello, friends. I'm glad that I got this opportunity to conduct a webinar for you all. I am sure that this will be a great learning for you all, and let us start now. Now, let me introduce myself first. My name is Sumit Mittal. I am the CEO and founder of Trendytech. I've completed my master's from NIT Trichy in the year 2013, and after that, I have worked for 7 plus years in companies like Cisco and VMware. And majorly, my area of work include big data, and that's why I'm really passionate about this technology stack. And from the very beginning, I always had a passion to teach as well. So now I have quitted my job since last 1 year. I have started my own startup, Trendytech, and I am following my own passion. I train working professionals as well as students on big data. It's a high-end technology and one of the hottest technology in current IT industry. Now, my passion could reflect with this consistent 5-star Google rating, which I have achieved consistently over the years. So, let us start now. What is big data according to you? That is the very first question. Now, if I ask this question to many of you, everyone have their own definition. For example, if I ask it to someone, he might say that big data means if the data is so big that I cannot store it on my machine, right? So you might get different definitions from different people about what is big data, right? Even if you ask me, I will say that I am using a Mac machine. If I am not able to store the data, it is big for me. That is my definition. And it's perfectly fine if you have your own definition for it. But there is one formal definition which has been given by IBM. So IBM gave a formal definition, right? So basically, IBM says that any data which is classified by three V's is considered to be as big data. Now, this is a very famous definition, and let us see what are these three V's as per IBM. Now, these three V's are volume, variety, and velocity. What is volume? As the name indicates, that the volume of data is probably too huge that we are saying it's big data. The volume is so huge that you might not be able to store it on a single machine, right? So this is what volume indicates. Might be few petabytes of data or few terabytes of data that you are not able to store it on a single machine. That is volume. I mean, it's very easy to understand what is volume. Now, what is variety? When you go to a sweet shop, you say, okay, what all varieties do you have? That means, what all kinds of sweets do you have? Similarly, in context of big data also, variety means the same. Different kinds of data. We can have structured data, unstructured data, semi-structured data, right? So let me write it here for your sake. So volume indicates huge amount of data which we cannot store on a single machine. This is what volume means. Now when we talk about variety, it means different kinds of data. And when I say different kind, I would mean structured, unstructured, and semi-structured. Right? These are the different kinds of data. And when I talk about structured data, I refer to my RDBMS tables. Right? For example, a table in your Oracle or a table in your MySQL is structured data because data is in the form of rows and columns. Now, what is unstructured? So, unstructured is probably your images, your videos, even your log files. like web server logs. These are also unstructured. So log files, because they do not have any structure. Semi-structured is which have partial schema associated or partial structure associated. For example, it can be your XML, your JSONs, etc. So in your big data environment, you have to handle all this, right? So that's what variety is comprised of: structured, unstructured, and semi-structured. So the first V was volume, the second V is variety, and velocity. So the third V is velocity. Now velocity refers to, velocity refers to the speed at which new data is coming in. For example, consider you have a system where you are handling 2 terabytes of data. Fine. What if tomorrow new data comes in? I mean, can you discard that new data? No. New data is very, very important and you cannot discard, right? That is where you need to make sure you are handling the incoming data, even though it comes with the increased pace. And that is what velocity refers. The speed at which new data is coming in. And you need to tackle that. Right? For example, consider the example of Big Billion Day, which Flipkart runs, right? So Flipkart gives a lot of deals on Big Billion Days and all. Even though someone like you who never visits Flipkart might be tempted to visit Flipkart on that day to see what are the deals, and you might end up making a purchase. Don't you feel Flipkart will have high velocity on their web page during those days compared to normal day, right? So you need to tackle velocity. All the new incoming data you have to handle gracefully. You cannot discard it, and that is what velocity is. So these are the 3 V's as mentioned by IBM: volume, variety, and velocity. And these are the characteristics of big data as per IBM. Right? So you can see this. And now, if you are someone who scrolls internet a lot, and if you search for definition of big data, you will get a lot of variants. You will find 4 V's, you will find 5 V's, you will find 7 V's, and you might end up finding 11 V's too. But now we cannot keep on talking about V's only, right? 4th V is still somewhat relevant, and let me talk about it, and then we won't talk about any 5th V, 7th V, all that. So what is the 4th V that comes in the definition of big data? It is referred to as veracity. 4th V is nothing but veracity. And veracity refers to the nature of the data, where we say data is not clean, right? Data is not clean. For example, consider you have a data where you have a lot of missing values, a lot of nulls are there. Age is negative. Is it possible age is negative? No. That means there are data quality issues. The data is not clean, right? Data does not have a sound quality. And that is what veracity means. Nature of the data where we say data is not clean. So do not expect in your big data environments you get clean data. No. You might get a data which is not clean, which has quality issues, and you need to tackle that. So this is the 4th V. So we have talked about 4 V's: volume, that means expect huge amounts of data. Variety, expect different kinds of data. Velocity, expect you might get data at a very quick pace. Veracity, expect that data might not be clean. You need to tackle that. These are the 4 V's as per IBM which characterize big data. Now question comes, why big data? Big data, if we are learning, it's one of the trending technology, that's okay. But why are we learning big data? Or why are we trying to learn this technology stack? There should be some purpose, right? Some of you might say, okay, I am learning it to get a job. I mean, that's okay. But you should be handling some business use case when you are learning this technology. What is that business use case you are trying to solve? Right? Because you do not end up learning something just because it will fetch you a job. It will fetch you a job because it solves a purpose. What is that purpose? So if I ask you, can you tell me one line problem statement that you are going to solve using big data? What is that problem statement? That problem statement is nothing but big data is used to process huge amount of data. Big data is used to process huge amount of data. That means you are learning this big data technology stack to solve or to process huge amounts of data. That is the problem statement you are going to solve. So to process huge amount of data which traditional systems are not capable of doing. Because if they were capable of doing, we would not have come here. Your traditional systems fail to process huge amount of data, and that's why you are using big data technology. That's the one line problem statement, simple. Okay, so you understood, you are learning this in order to process huge amount of data. Now let me ask you, can you directly process something? No. Before this, there is something that is required and which is very, very important. And that one thing is, first you need to worry about how you need to store the data and then worry about processing. Because without storing, you cannot think of processing your data. I mean, you cannot process your data in air, right? It has to be stored somewhere properly. So before processing huge amount of data, a step comes where you first think that how you need to store huge amount of data. So first step would be store huge amount of data which your traditional systems are not capable of doing. And then second thing is that once you have stored it properly, you worry about processing. It has to be in sequence, first store and then process. So big data then process huge amount of data which your traditional systems were not capable of doing. So two things, first store and then process. To process huge amount of data, we first need to store it. Are our traditional systems capable to store such massive amounts of data? No, they are not. That's why a different storage mechanism is required to store it. So first worry about storage. Once you have stored it properly, then worry about processing. Right? So store huge amount of data. Traditional systems are not fit to store such huge amount of data. So the first requirement is store. Then second is process, because our traditional systems cannot process it, right? So let's say if someone asks you, what are the requirements to design a good big data system, right? If someone asks you what are the requirements to design a good big data system, then the first requirement is you need to first worry about storage. Then second, you need to worry about processing. And then there is a third, which is also quite important, right? And that is scalability. That means your big data system should be scalable. What do I mean by that? I mean by this is, let's say you are working in an IT company. Your manager asked you, right, that can you design a system which can handle 20 terabytes of data? Now you designed a fantastic system which is handling 20 terabytes of data gracefully, very nicely. I mean, beautifully it is doing this thing. Now your manager is happy, super happy. Now tomorrow your manager comes back to you and asks you that can you please, I mean, incorporate a change that instead of 10 terabyte, I want to handle 100 terabytes because the requirement has changed and the requirement has grown. Now you cannot wave your hands and say, boss, you gave me a wrong requirement. Rather, you need to incorporate his change and make sure your system is capable enough to handle 100 terabytes of data. Right? And if you are able to accommodate this change, then your system is scalable. That means your system has scaled as per the growing demands. And if you are waving your hands and saying, boss, no, I cannot do it because my system is not capable to do that, that means your system is not scalable. So remember, whenever you are designing a good big data system, it should be scalable because the requirements in IT can keep on changing. Right? Make sure you have a scalable system and you are able to incorporate changes when required. Right? So third requirement to design a good big data system is scalability. Scale easily to accommodate growing requirements. So these are the three requirements to design a good big data system. First, you need to tackle storage. Second, you need to tackle processing. And third, you need to make sure your system is scalable. Store, process, and scale. Now, in this store and process might seem to be very, very obvious. But let's talk little more on scalability. So when I talk about scalability, let me talk about a fact that a system can be designed in two ways. One is a monolithic style and other one is a distributed style. Now we need to understand what is a monolithic system and what is a distributed system. Monolithic system, as the name suggests, mono means one big powerful system. Remember, it is just one system but will be powerful system, holding lot of power, trying to act like an elephant, right? Holding those many resources. On the other hand, distributed means multiple smaller systems. Monolithic means one big powerful system. Distributed means multiple smaller systems. And each system technically is called as a node. Right? So for example, you can see here we have 6 nodes. And this together is called as a cluster. So we have a 6 node cluster in this case. Now each node is not as big as this monolithic system. Ideally, in monolithic we have one system but very, very powerful. And in distributed we have multiple smaller systems, a cluster of smaller systems. Let me talk about what do I mean by resources. When I say resources, I basically mean 3 things. Number 1, I mean CPU. For example, you relate it to your laptop. In your laptop, you might have, 2.31 gigahertz dual core processor, quad core processor, right? So that is nothing but 2 cores, CPU cores, right? Then we have your RAM, right? For example, in your laptop, you might have 8 GB RAM. And then we have hard disk. For example, you might have 1 TB hard disk, right? Now technically this CPU cores is called as compute, right? Compute resource. RAM is called as memory and hard disk is called as storage. Basically compute, memory and storage, these are the 3 kind of resources available on machines. So generally when I talk about resources, I mean compute, memory and storage. I hope you are clear. Now let us talk about which system is better, monolithic or distributed. Most of you will say distributed, but I am sure you might not have a very convincing answer. Right? Now let me give you a convincing answer why distributed is better when dealing with big data. So consider you have a monolithic system. Monolithic. That means one system. Now this system has, let's say, 64 GB RAM, right? And it has, let's say, 5 TB hard disk, and it has 16 cores CPU. Okay. Now this is gracefully able to handle, some amount of data. Now what if your requirement increase 4 times tomorrow? Then what you will do? It becomes really very challenging to add more resources on this system, right? It becomes very challenging. And even if you are able to add more resources to this system, then the performance won't be adequate. What I am trying to convey is, consider to this system, you have given some X amount of resources and you are getting a performance of Y. With X amount of resources, you are getting a performance of Y. Now, what will happen, or what you want to do if you want to get 2Y performance? That means, if you want double the performance, what is required? Now, you might say, I will double the resources, or I will invest twice in the system, and my performance will get double. Right? Okay, might be, that's fine. What if again you want to get 4 times, or you want to again double the performance, right? Again you want to make it 2 times. Then what you will do? Then you might say, I will again make it double. No. After a certain threshold has reached, when you double the resources, right? When you make the resources as 2x, the performance will be less than 2y. That means when you double the resources, the performance won't get double, right? And this is a serious limitation, because you are investing twice in the system and you expect it to give you twice the results, but it might not happen after a certain threshold is reached. And this is why, or this is the limitation with a monolithic system. That's why you won't see a system with, let's say, 2 TB RAM. Have you seen a system with 2 TB RAM or 1 TB RAM? At least I have not seen. Because even if you see a system with 1 TB RAM, it won't justify for the performance. There will be a performance dip, right? It won't behave like that, right? So you can see the limitation with a monolithic system. That means when you try to add resources, then it won't give the performance in a justified way, right? It does not justify for the performance based on the resources you give. On the other hand, if we talk about a distributed system, right? If we talk about a distributed system, then consider you are having a 4-node system, a 4-node cluster, right? And you are getting a performance of Y. Performance is Y. Now, what if you want to get 2Y performance or double the performance? As simple as that, you need to double the number of machines. That means instead of adding more resources in one machine, you increase the number of machines. So what you need to do is to double the performance, you need to double the number of nodes, right? To make it 8 machines. If you again want to double, make it 16. If you again want to double, make it 32. Right? If you again want to double, make it 64. Like that. So this is a truly scalable model. Right? So distributed is a truly scalable model where instead of adding resources to one machine, you keep on adding more machines. Right? And by the way, in monolithic, when we keep on adding resources to a single machine, it is called as vertical scaling. In monolithic, when we keep on adding resources to same machine, this is called as vertical scaling, which is not true scaling because it does not scale after a certain point. And in case of distributed, we get horizontal scaling because we keep on adding new machines horizontally, and this is true scaling. I hope you are clear. So you can see this in monolithic. If we, let's say, have resources RAM, hard disk and CPU, right? If we double the resources, will we get double the performance? No. And that's why I'm saying it is not scalable. A scalable system is the one where if I double the resources, I get double the performance. Right? In case of distributed system, if I add more machines, I will get more performance. If I double the machines, I will get double the performance. And this is why I say it's a truly scalable system. So in monolithic architecture, whatever scaling we say is vertical scaling and is not true scaling. And in distributed architecture, whatever scaling we get is horizontal scaling and is true scaling. So which one is good now? So you remember when we discussed about the requirements for a big data system, we said first we need to think of storage, then we need to think of processing, and we need to make sure our system is scalable. So which one is a scalable system now, monolithic or distributed? Distributed. And that's why to make sure a big data system is scalable, all the good big data systems are made on a distributed architecture and not on monolithic architecture. And that's what is a perfect fit for big data systems. I hope you all are clear with this. So that is why all good big data systems are based on distributed architecture. Now let us continue our learning. And let us ask a question, what is Hadoop? I know many of you were waiting for this because Hadoop is something which you have heard and you are curious to know what is Hadoop. Hadoop is a framework to solve big data problems. This is just a one-liner solution or definition I am giving you. Hadoop is a framework to solve big data problems. Now, why do I say it's a framework? I say it's a framework because it is not just one thing like Java that you learn and done, right? Rather, it's a bunch of tools and technologies which come together to solve a problem. It's not one single thing. Rather, it's a bunch of tools and technologies which I'll be telling you in some time. And it is mainly used to solve big data problems. Now, let us talk about evolution of Hadoop. How Hadoop evolved. Google in the early 2000s realized that whatever existing web search they have and whatever processing required for that, they have to go with a distributed architecture. Google realized that they need a distributed architecture to tackle their web search requirements. This was in the early 2000s. Google realized that. So to tackle their growing demands, they felt that Since they were based on monolithic architecture at that time, they understood it won't scale and they felt there is a need of distributed architecture, right? And with the growing demands, they felt they have to design some big data technologies because the data was growing for them. So what happened in the year 2003? In the year 2003, Google gave a white paper, right? Google gave or released a paper, and this paper they gave is to tell how to store huge amounts of data. So you remember, to design a good big data system, three things were required, right? Storage, processing, and scalability, right? So Google in 2003 gave a paper where they mentioned if you have huge amount of data which you cannot store on a single machine, then how to store it on a cluster of machines by dividing the data. So in 2003, Google gave such a paper on distributed storage. So this paper talked about that if you have huge amount of data which cannot be stored on one single machine, how to divide this data into smaller parts and store it on a cluster of machines, right? And this paper technically or officially was called as GFS paper, which stands for Google File System, right? This paper by Google is still available on Google. You can Google it and you will find it interesting. Now in the year 2004, they have to give something on processing because storage they have tackled, and they gave a paper on distributed processing, right? In this paper they talked about that when our data is stored on, let's say, 10 different machines, how to process it on those 10 machines in an efficient way, because your traditional models won't work. Whatever earlier Java code you used to write or Python code you used to write can solve a problem when data is stored on just one machine. But now data is stored on 10 different machines. Then how to process that data properly? They gave a paper on that. And this paper is called as MapReduce paper. MapReduce. Right? So they gave two papers, GFS for distributed storage and MapReduce for distributed processing. So in 2003, they gave a paper on distributed storage called as GFS. And in 2004, they gave a paper on distributed processing, which is called as MapReduce. Both the papers are available on internet. You can Google it if you want to know more or if you are curious to see these papers. Right? Okay. Now these are papers, and papers alone are not good enough. Someone should be implementing these papers. And that's when Yahoo pitched in. Yahoo in the year 2006. What Yahoo did is, Yahoo took the GFS paper and MapReduce paper. So Yahoo took these two papers and Yahoo gave implementations for this. That means earlier these were just the theoretical concepts, but Yahoo gave implementations, right? And the main person who was leading the effort was dough cutting. Right? Dough cutting. Dough cutting was the main person who led the effort behind it. Now what they did is, they took the GFS paper, they implemented it, and the name of implementation was HDFS. Stands for Hadoop Distributed File System. Right? HDFS stands for Hadoop Distributed File System. Something very commonly used in big data world. Right? So what is HDFS for? It is used for storing huge amount of data in a distributed manner across a cluster of machines. Now they implemented the paper MapReduce meant for distributed processing, and the name of implementation is also kept as MapReduce. The name was not changed, right? So HDFS is the implementation of GFS paper, and MapReduce is implementation of MapReduce paper, right? So let us see this. So Yahoo took these papers and implemented it. The implementation of GFS was named as HDFS, stands for Hadoop Distributed File System, and the implementation of MapReduce was named as MapReduce, unchanged, right? And these two, HDFS and MapReduce, forms the core components of Hadoop in first version of Hadoop. That means the first version of Hadoop has two core components, HDFS and MapReduce. Let us see this. So Hadoop 1.0 has two core components, HDFS for distributed storage and MapReduce for distributed processing. These are the two core components of Hadoop. Now in the year 2009, it came under Apache Software Foundation, known for its open source. And I hope you know what is the meaning of open source. Now do not tell that it means free. Of course it is free, but also it means that the source code is available publicly. You can feel free to contribute to it, make changes to it, customize it as per your requirements. Right? So Hadoop is under Apache Software Foundation. I hope it is clear that Hadoop 1 has two core components, HDFS and MapReduce. Now do not tempt to say HDFC. It is not HDFC. It is HDFS. I see many of the people who are new commonly make this mistake by saying HDFC. Right? So the entire impression goes down when you say HDFC. It seems that you are very new to it. Then what happened? In the year 2013, they felt that this Hadoop 1 has some limitations, right? And they came up with major performance enhancements. And they released the second version of Hadoop. In Hadoop 1, they felt that there is a limitation. That's why they came up with Hadoop version 2. Right? Now the limitation what they felt is, they felt that Hadoop 1 has two core components, HDFS and MapReduce. I will just write MR. It is not Mr. It is MapReduce. Right? For my convenience, I have written it in short. Now, what they felt is this MapReduce component is a very bulky component and has to do a lot of work. Now, if someone has to do a lot of work, they might get overburdened. I mean, consider a case like Virat Kohli, is a very good player. But can you expect him to do the entire work of the team? No. He will get overburdened and again won't perform well in that case. Right? That's what happened. They felt this MapReduce is doing more than what is required. So what they did is, they felt that can't we divide MapReduce into two parts? Or can't we take some of the functionalities of MapReduce and give it to a new component? That's what they did in Hadoop version 2. So HDFS is almost like this. And this MapReduce they broke down into two parts. One is still called as MapReduce, but with lesser features. And they introduced a new component called as Yarn. Right? That means some of the functionalities of MapReduce were given to Yarn. And Yarn stands for Get Another Resource Negotiator. right? YAN stands for yet another resource negotiator. Now, what is HDFS for? What is HDFS for? HDFS is for distributed storage. That means it will store your data. Now, what is MapReduce for? It is for distributed processing. That means you will write some code and all, and it will execute. Then what is YAN? Now let me ask you, what is Windows on your system? You will say it's an operating system. Correct. What is the role of operating system? The role of operating system is to manage the resources, right? Is to make sure the resources are used in best possible way. A resource manager. Similarly, YAN is also like an operating system, managing the resources for you. But again, it is not sitting just on top of one system. It is sitting on top of multiple systems, monitoring the resources of all the systems, or managing the resources of all the systems, not just one. So I would say YAN is like an operating system in a distributed environment. You can compare it with your Windows. Windows is for just one system. YAN is sitting on top of multiple systems, managing the resources underneath, right? And will make sure the resources are used in the best possible way. And that's why the name resource negotiator. Because if someone needs resources, they will negotiate the resources from YAN, because YAN will be allocating the resources. And this is the Hadoop evolution. In 2003 we got HDFS, GFS paper. In 2004 we get MapReduce paper. 2006 Yahoo implemented it. 2009 it came under Apache Software Foundation, and 2013 Hadoop 2.0 came into picture. And this is how Hadoop 1 looked like. We have two components, HDFS and MapReduce. In Hadoop 2 we have three core components. YAN was introduced, and you can see MapReduce was split into two parts. Earlier, MapReduce was doing the work of YAN also, and that's why it is doing too much, right? So Hadoop 1.0 has two core components, HDFS for storage, MapReduce for processing. Hadoop 2.0 has three core components, HDFS for storage, MapReduce for processing, and YAN for resource management. YAN is for resource management like an operating system. HDFS is for distributed storage, MapReduce for distributed processing, and YAN is for resource management. Now there are a bunch of ecosystem technologies which surround this Hadoop core. We have talked about three core technologies, that's fine. So you can see this. So at the heart of it, we have the Hadoop core, where we have three core components, HDFS, MapReduce, and YAN, right? And a bunch of ecosystem technologies surround it. Hive, HBase, Coop, Oozie, Pig, Spark, and there are many others. Now, what is the purpose of these ecosystem technologies? We need to understand that. Let's start with Hive. Now, before talking about Hive, let me tell you, for processing, which is the core component here, it is MapReduce, right? So MapReduce is for processing. But let me tell you, the code that has to be written for MapReduce has to be written in Java, and which is very, very difficult to write. I mean, it is one of the toughest job to write a MapReduce Java code. Now, what does that mean? People who know Java only can interact with Hadoop, right? That's unfair. There should be ways for other people also to work on Hadoop even if they do not know Java. And Hive provides exactly that. Hive says, okay boss, if you do not know Java, I am there to help you out, do not worry. If you do not know Java, then at least you will be aware of SQL, right? Then even if you do not know SQL, then I cannot help you. I mean, you do not know Java, you do not know SQL, then even I cannot help you. But if you know SQL, I am there to help you out. What you can do is, you can write things in normal traditional SQL style, and I will take the SQL style from you and will convert it to the tough or difficult Java MapReduce code. That means you write the way you know SQL, and I will do the hard work of converting it to MapReduce Java code and will execute. So Hive does this. Hive says, do it easy way, I will do the hard thing. So from your end, you will write simple SQL kind of thing, right? And Hive will convert it to MapReduce code and will trigger it on the cluster, right? So what is Hive? Hive is nothing but a data warehouse on top of Hadoop for providing data query and analysis. That means it's a wrapper on top of MapReduce which makes your work easy. Earlier you have to write 100 lines of Java code, but now you are writing one line of SQL kind of thing, which is easy. Writing one line of simple SQL is easy, or writing 100 lines of Java code is easy. Even if you are a hardcore Java developer, you might think, okay, let me also write one line of SQL, right? So Hive is given to make the life of developer easy. And just to let you know, Hive was developed by Facebook, right? Hive is given by Facebook. And Hive is very, very important from an industry perspective. They ask a lot of optimization techniques inside it, right? But the only purpose of Hive is to ease the work of a developer. Instead of writing hundreds of lines of Java code, you can write few lines of SQL kind of syntax, and this will make your life very, very easy. But again, underneath it is a MapReduce job. Now let's talk about pig. Let me tell you first of all, in industry pig is not used today. Now I'm sure many of you might not even listen what I will say, right? Because you know in industry it is not important and you might skip this. But at least you should have a slight idea that pig is a scripting language, just like your shell scripting or something. And the only purpose pig is used is to clean the data and convert it from unstructured form to structured form, right? For example, you have a log messages which is unstructured data. You might want to create a table out of it or create a structure out of it. You can use pig script to do that, to convert from log messages to a table, unstructured to structured. Also, if you feel your data has some quality issues or you want to clean your data like ETL operation, you can use pig to do that. Again, pig is also a MapReduce internally, right? Feel free to write 200 lines of Java code for one line of simple pig script if you have a lot of time, right? No one prefers writing MapReduce code because you end up writing hundreds of lines of MapReduce Java code, which is very, very tricky in industry. That's why you end up using these ecosystem technologies which ease out your work. So you have understood Hive, you have understood pig. Now many people compare whether pig is better or Hive is better. Let me ask you, what do you say? Is pig better or Hive better? What's the answer? Some of you will say Hive is better because pig is not used. No, that's not the answer. The answer is, it's like comparing apples with oranges. You cannot compare pig and Hive. Both are for two different purposes. I won't say both of them compete with each other, rather both are friends and complement each other. For example, when you are getting your data, you might want to clean your data using pig. You might want to create a table out of it using pig. And then Hive knows how to deal with tabular data in easy way. Then Hive will take it from there and do whatever you want. That means pick first to clean the data, to convert it to a structured form, and then use Hive to process that. Both are helping each other out, both are complementing each other rather than competing with each other, right? So understand that we cannot compare these two, both are for two different purposes. Now, what is Coop? Now, I will explain you this way. You might go to a ice cream parlor and you see there are containers capped with vanilla ice cream and strawberry and lot of other flavors. Now you say that give me one scoop of ice cream. What that guy do is he takes the scoop and then again puts it on the cone. That means he transfers whatever the ice cream content from the container to the cone. That means transferring. So this is just to make you explain. Scoop is nothing but to transfer your data from traditional databases to Hadoop. Consider you have data in your Oracle database, employee table. There is an employee table in your Oracle database or MySQL, and you want to bring it to your Hadoop environment. How will you do that? Using Scoop. Also, you can transfer the data from your Hadoop environment to your databases. So it's a bi-directional connectivity from traditional databases to Hadoop or Hadoop to traditional databases. So you can see a command line interface for transferring data between relational databases and Hadoop. Now, what is HBase? HBase is a NoSQL column-oriented database which runs on top of Hadoop. Right? It's like MongoDB or something. You might be aware of MongoDB, that's why I'm comparing. It's like a NoSQL distributed database running on top of many machines. And what is the need of database here? Why do you need a database on top of Hadoop? That's the question. Now, before talking about it, let me talk about two things. There are two things. One is processing and other one is searching. Can you tell me the differences between processing and searching? What is processing according to you and what is searching according to you? Consider, let's say I have an employee table with 1 lakh records. 1, 2, 3, 4, 5, 6. 1 lakh records are there. Now in this, each employee has a salary. Now if I want to find the sum of all salaries of all employees, then don't you feel we have to consider all 1 lakh rows and then do some aggregation in order to find sum of salaries of all employees? Right? That means we are considering all 1 lakh records for the processing. And this is what I will call as processing because I am doing aggregation on top of all records. If I have to find sum of salaries of all employees, then I will say this is processing. This is processing. Because I am taking into consideration a lot of data. Now, on the other hand, if my query is select star from table where employee ID equal to 1034, is this processing or searching? Now, this is searching, right? Because I am saying or pinpointing one record and saying, please give me this record. This is searching. Now, one thing I would like to say, whatever you have learned till now, MapReduce, Pig, Hive, all are meant to do processing or quick processing. None of them were meant to do searching, right? None of them can do searching. If you want quick searching, then you require a database. And that is what is the use of HBase, which acts as a database for quick real-time searching of data. So if you have a requirement of processing, go with Hive. If you have a requirement of quick searching, go with HBase. As simple as that, right? So I hope you can clearly understand Hive is meant for processing, HBase is meant for searching. Okay, let's talk about Uzi. A fancy name, right? Uzi. What is Uzi? Uzi is nothing but a workflow scheduler. Right? Consider you have a job which you want to run 8 p.m. every day. Then you can schedule it using Uzi. It's like a no-brainer that instead of you going to a system clicking a job every day 8 p.m., you schedule it in an automated way using a workflow scheduler like Uzi. Having said that, nowadays Airflow is also one of the most trending schedulers. Uzi and Airflow are the two main schedulers used in big data industry today. So this is for creating a workflow and scheduling it. A workflow schedule. Now comes the buzzword Apache Spark. And I am emphasizing this because this alone is equally important. Whatever we have learned till now is on one side and Apache Spark is on one side. This is the importance of Apache Spark in today's big data world. If you do not know Apache Spark, do not call yourself a big data developer. That's the importance of Spark in today's world. Then let's talk about what is Apache Spark. What is Apache Spark? Let me give you a one-liner definition to this. Apache Spark is a general purpose in-memory compute engine. I am using three keywords here. Spark is a general purpose in-memory compute engine. I will explain you this now. Apache Spark is a general purpose in-memory compute engine. Now, when we talk about Hadoop, what are the three core components? HDFS for storage, MapReduce for processing or computation, and Yarn for resource management. Now, what is the compute engine here? MapReduce in case of Hadoop. What Spark gives you is just a compute engine. It does not give storage and resource manager. It says I am just a compute engine, nothing more than that. Right? So is Spark a replacement of Hadoop or is Spark a replacement of MapReduce? What can be the right statement? Some of the people who are very new to big data industry, they think Spark will replace Hadoop. I mean, is it fair to compare three components with a single component? No. However, you can compare computation with computation. You can definitely compare MapReduce with Spark because MapReduce is for computation and Spark is also for computation. But you cannot compare Hadoop with Spark because Hadoop gives you storage unit, computation unit, and resource manager. However, Spark gives you just computation unit, right? So you can see you can replace MapReduce with Spark, right? So you can remove MapReduce here and bring in Spark. So you have HDFS, Spark, and Yarn. And this is a very famous combination used in industry today. This is also called as Spark on top of Hadoop. Hadoop is giving its own storage and resource management, and Spark is giving its quick computation. So Spark is nothing but a plug and play compute engine. That means it is just a compute engine, but it needs two more things to work with. What are those two things? One is a storage unit and one is a resource manager. Spark says, I am not worried. You bring these two things of your choice, I will work fine. I am not tied up with any particular storage or resource manager. Feel free to bring any storage of your choice. Feel free to bring any resource manager of your choice. I have no issues. I am a plug and play compute engine. So plug it with any storage. It can be your local storage. It can be HDFS or it can be even Amazon S3. And you plug it with any resource manager it can be Yarn, it can be Mesos, it can be Kubernetes, anything, right? So plug it with any storage of your choice, plug it with any resource manager of your choice. So you can see this. For computation, you can bring Spark. For storage, you can have your local storage. You can have HDFS. You can have Amazon S3. For resource manager, Yarn, Mesos, Kubernetes, anything. And the current industry trend is, for storage, they use HDFS from Hadoop. For resource managers, they use Yarn from Hadoop. And then they bring in Spark for computation, because Spark is better than MapReduce, right? So this is one of the industry trends. And this is also called as Spark on top of Hadoop. Having said that, you understood all this. Now, in which language we need to write the Spark code? Just like MapReduce code was written in Java, in which language we can write the Spark code? Now let me tell you, there are 3 languages which are supported: Scala, Python, and Java. Now which one is most famous? Scala is the top choice. Why Scala is the top choice? Because Spark itself is written in Scala language, and Scala gives you the best performance for it. Any new feature releases also will be available for Scala first, right? So Scala gives you the best performance among all. And the second preferred language is Python. Java is the least preferred. So I would say, if you are getting 10 job opportunities, if you see, 6 of them will ask Scala, and 4 of them will ask, or 3 of them will ask Python, 1 will ask Java. So Scala is the top choice because Spark itself is written in Scala. So Spark is written in Scala. However, Spark officially supports Java, Scala, Python, and R. And Scala is the top choice for a big data developer. So I hope with this you got a fair enough idea about big data, whatever I have covered. What we have covered is, first we covered, let me quickly recap it. First we covered what is big data. And we talked about the 3 V's definition as per IBM. Right? We also talked about 4 V's. Right? And then after that we talked about what is the problem statement you are trying to solve. And we said the problem statement we are trying to solve is to process huge amount of data. And to process huge amount of data, we need to store the data first. So that is again a primary requirement. And also it should be scalable. So to design a good big data system, we have to consider 3 things: store, process, and scale. And then we talked about a system can be designed in 2 ways: monolithic versus distributed. And we said distributed is scalable. Right? Having said that, after that we talked about what is Hadoop. We talked about the evolution of Hadoop. Right? We talked about Hadoop 1 core components, where we have HDFS for storage and MapReduce for computation. Then we talked about Hadoop 2, where Yarn was introduced for resource management. And then we talked about bunch of ecosystem technologies like Hive, Pig, Scoop, HBase, Oozie, and even Spark. And Spark is something which is very, very important and is an alternative or replacement of MapReduce. Right? Spark is the buzzword in today's era. Right? So you remember I said Spark is a general purpose in-memory compute engine. So you understood it is a compute engine purely. And since it is in memory, it is 10 to 100 times faster than MapReduce. Just because it is in memory. And why I say it's general purpose? Because you can do much more than map and reduce. A lot of other things are supported now. Right? That's why it is much more generic in nature. You do not have to just bound yourself to map and reduce. So MapReduce is something which is very, very fast, which is much more generic, and is the trend of today. Something which in interviews is asked a lot. A lot of interviews start on a Spark and end on Spark. That's how the importance of Spark in today's big data industry. As I mentioned, I offer trainings for industry experts as well as students on big data. I would tell about my course. I've been conducting this course for last 3 years now, and I have a consistent 5-star Google rating. If you see, and it's a 16 weeks extended course. I have mentioned 15, but now it's extended to 16 weeks. It's a full-fledged 4 months course. 150 plus hours of quality learning I provide, which includes bunch of projects and assignments and assessments, interview series, lot of other things. So it's a full-fledged course. If someone do this, they are prepared to crack topmost companies. I mean, in case if you are looking for it, you can approach me. I can guide you definitely. Right. So this was about my course that I offer, and here are my details. If you want to connect with me on LinkedIn, here is my LinkedIn ID. I have a website called as bigdatabysumit.com. If you want to visit, this is my phone number. If you want to reach me out for any doubts or any help you need, my email ID, and also I have a YouTube channel with the name Trendytech, where I keep on uploading new videos. So with this, I have covered what I wanted to cover, and I hope you have liked the session. So I'll be glad to get in touch with you personally. You can feel free to reach me out for any help you need or for any guidance you need. I can mentor you and help you out, because I have a passion to teach, and I want you to succeed in your careers. So if you need any help related to any big data stuff, feel free to reach out to me.